My name is Amir. I'm Director of Solution Architecture. I have been working for InterSystems for as long as I can remember, more than 20 years. And we're going to take a sneak peek at what is Smart Data Services. This is the agenda. And to make this really fun, I want to start with a demo. Okay, so let's pause the PPT and just go directly to the demo, and then we'll come back here to the PPT, and after you see what I'm going to show, we'll discuss it a little bit. So this is what we call the canvas. You are seeing here a bunch of stuff deployed. So we have here an IRIS box that I deployed, the speed test, and as an architect, I can go to a catalog and deploy whatever I want. If it's too small, I can make it bigger, right? So as an architect, I can go to a catalog of services and deploy whatever I want. So the catalog is right here, and just like an app store in your phone, you can pick something and deploy. I will search here for IRIS, and I'll take IRIS, I'll give it a name, Global Summit DB, and pick a size, 2 cores, maybe more, 4 cores. Pick a size for the disk, right? I can go custom as well. I want to get access to the management portal of IRIS, so check this box here. I need to provide some secrets like the IRIS license, and secrets to pull the images from containers.intersystems.com. Maybe I want mirroring, and I have to accept the terms and conditions, and I can just click add, and now you have this blinking box here, and I'm deploying IRIS on the cloud. So this is the first demo. We are going to be seeing 4 or 5 demos. So now that you have seen this, let's go back to the PPT. So what's the goal? Every large organization has many systems, CRM, ERPs, right? Custom systems built at home. And we want to empower users to go to a catalog and deploy whatever they need to work with these systems. I need to bring data from the CRM, from my asset management system, from the markets. I need price data. If I'm a financial services institution, I need price data, trading information, whatever that is. I want to bring this data in. So these 2 boxes, let's see if I can use my cursor. Yeah, these 2 boxes here, those are 2 services that I took from my catalog. And as an architect, I'm deploying, and then I will just go there and configure it. So I'm trying to make it really easy for you to find what you need and deploy it. And you can keep going. And maybe now I need to expose all the data that I'm aggregating from these systems as an API for a business partner. If I'm doing, open banking. Maybe I need to create a custom interoperability connection here for my regulator that is now asking for my data in a crazy way. So I just go to the catalog, pick what I need, deploy it on my canvas that you just saw on the previous demo, and you keep going. And we want this to be useful for partners as well. I'm going to talk about partners, but this catalog should not have solutions only from InterSystems. It should have solutions built by you, by our customers. So we will put something in there, but we want to create a framework so that anybody can quickly build something and put on a catalog and make this visible to all our customers. So if you are a partner and you have a cool solution, we want to give you visibility. So you have been hearing a lot about smart data fabrics and smart data services, right? So I just put this slide here to make this differentiation. A Smart Data Fabric is it's not a product. You don't buy a Smart Data Fabric. You build it. It's an architectural pattern. In opposition to that, Smart Data Services is a product. We're building a product, which means that there is a canvas you saw when we started. There is a catalog. There are documentation about how do you build something for this catalog, right? So it's just like Apple, and if you are an Apple developer, Apple will give you all the guidelines. Here is the SDK for you to build for the App Store. Here are the rules, and you can build for it. And then we are providing you with several tools in the canvas that will help you to compose these services together. And we're going to be talking more about that. So it is a product. The second line there about Smart Data Fabric is I have to go there and install my stuff myself, right? And with Smart Data Services I just pick it from the catalog and I sit back and wait for it to come up, right? And many of the things are sorted out for me already. So that is that's where we are going, right? So one of the things that Smart Data Services provides to support better composability, I hope I'm saying that right, is dependency injection. So I'll just briefly cover it here and we'll see another demo. So let's say you have an application that requires, in order for it to work, it really needs to talk to an IRIS database, a JDBC endpoint, okay? So we have my speed test application there that you will see, but it could be, for instance, a partner solution to find patients that are at risk of developing diabetes. And for this to work, I need you to point me to your FHIR repository. I need a FHIR endpoint. So these kinds of dependencies, they are very clear. Like some applications, they require a JDBC connection and find a data model at that end. Like I want to find a financial services data model at the other end, or logistic data model at the other end. The FHIR repository is another example, and so on and so on. PXV2, PXV3, XDSP, all these healthcare protocols, those are all endpoints that you could manifest, like I really need that. Here I'm going simple. Okay, this is a speed test application. It requires a JDBC endpoint. It's very simple. And you may have deployed two things on your organization there. You know, a FHIR repository, it offers a FHIR endpoint, and an IRIS database, it offers a JDBC endpoint. So which one, you know, could satisfy the dependency over there? And it's that simple, right? But if you establish these ground rules from start, and if you start packaging your applications and saying, what is it that you require to work? Do you require a PXV2 endpoint, a PXV3 endpoint, a FHIR repository endpoint? What is it that you require in order to be deployed and to work? If you declare that up front, you start promoting composability, okay? So it's a simple concept, but nobody does it, right? So we are trying to take a step into doing that. So let's come to the demo now. So going back to the canvas that we saw previously, I have the speed test deployed here, and it has, it's connected to an IRIS database, right? I deployed it just like I did deploying my Global Summit database here, right? I could come here and actually deploy another one, the speed test demo. Give it a name, pick a size. The speed test demo, you saw this demo this morning. Bob was using it to show how we can scale horizontally, right? It's the same test, and I can click here and say I want to see the UI of this thing. here I can, endpoint. I can pick the endpoint that I want to use. I want to use my Global Summit database, right? And I can keep going and give the credentials to access that database, pick the number of ingestion workers, query workers. So those are all machines that are going to be spun up to really stress that database. So I'm not going to deploy this one because I have it here already, but I can just, that's the end result. It gets deployed, right? And I can come here and open it up, right? So you'll see that this UI, it has many other components, but it's very similar to what you saw this morning. And it's an application. It could be your application that someone deployed, and it's talking to IDIS. So right now, it's pre-expanding the database. I should have run this last night. So this is going to take a while to pre-expand the database. We can leave it running here and proceed. If you have questions, take note of it. I will try to give you time to ask the questions. We'll have we'll be on the developers exchange as well. So I told you about partners. So basically, you have applications. Partners, they have solutions, but you don't have visibility. We want to change that. We want all our customers to see what our partners are offering. So that catalog that I went to, to deploy the speed test, your applications would be there as well. And you can develop this using any technology, but the same concept of composability is here. So the file repository would be in the catalog already, provided by InterSystems. Maybe you have a Kafka broker, and maybe here in the bottom, we may be providing as InterSystems a Business 360 or an asset management total view data model. So those are things that would be in the catalog. And then as partners, you could just pick whatever technology you want to develop these applications. So here is a very important piece of information. The applications on the catalog, they can be built with whatever technology you want. For instance, the bottom part of the screen, there is this Python application that may be doing some financial services or maybe running a machine learning model, whatever, but it needs data from our Business 360 canonical model, and we are storing data. I'll point if I can find it. Sorry, going back. Here, we're storing data here for you on the canvas, and all you're asking your customer is, please point me to your Business 360 database, your Business 360 canonical model, or please point me to your FHIR repository, okay? So you package this, right, and we put it on a catalog, so it will be very easy for customers to deploy. So what is the benefit of that? Visibility, and also if you're doing a proof of concept, customers will be able to find you over there and really get to try you with their own data. So all that challenge about, well, I can't build this because I can't give you my data. So we can't really do this proof of concept. We have to sign 15 contracts. Now you can tell your customers, just go there and test it with your own data. And maybe you, as a partner, will be supporting them. Also, we could provide you with a FHIR repository populated with synthetic data. So you could build your applications for that. Or a Business 360 data model with financial services data. So you could build for that. So we could help you that way as well. And all these solutions from InterSystems and our partners will be on the same catalog with full visibility to all our customers. So if you want to see an example of or a more complex application, so this is the speed test here. This is still pre-expanding. So we'll go check it on later. Let me see. We deployed one. I'll deploy another. So Business 360 is a solution that we have for financial services. I'll deploy it. It's just the same. Like you could be guiding your customer on this, and they could test this solution against their own data. Right, so here, I'll pick the data lake. So here I have a dependency injection. So I need to access your data lake. Because I'm Business 360, I need to access your data lake to start pulling data from it. And secrets again, and I can deploy it. So again, you see here, another line connected to the data lake, right? So we'll come back to these things that I'm deploying here. So, and we will be looking under the hood, okay? So I just want you to be familiarized with the canvas and how we can easily deploy stuff. So how does it work? So now we're going to talk about some technical things here. So first of all, we use Docker, we are using Kubernetes, we're using Helm charts. So we're going to be talking a little bit about all these things. So let's say you have an application and you're writing the front end in Angular. Right? It could be React, it could be pure HTML, and it's on your source control system, right? What do you want to do? You want to package this application for distribution. So in your build pipeline, you generate what you want to distribute, the final HTML, right? It could be your compiled code, your compiled jar files, whatever that is. And you add it to an image, a Docker image, that box over there, right? And you then push this image to a registry. A registry is this place on the internet where I can push my image so that all my customers can pull it. So it's a packaging thing. That's what I want you to understand. If you don't know Docker, just think it's a packaging solution. You're going to package your software in a box and make it really easy for your customers to find. And when it's time to deploy it, you can have I can have 2 VMs here connected with a load balancer, and you could just say, put my package there, and your software is deployed. It's that easy, okay? So in order to explain the other concepts, I went to our developers exchange and I found these to-do applications. Just to-do, a simple application built with Django and Iris as the backend. So it's a Python application with an Iris backend. And when I found it, it was this monolithic thing where this box that we're talking about, the container, had both Iris and Django together in it. Right? So one of the things that I did was to split this thing into 2, because the customer will be deploying Iris separately, and they are going to the catalog, and they are going to find this amazing application that will help them to sort their day out, and they will deploy and say, here, use the Iris that I have already there. So they are separated. So, and they are going to be composed when it's time to deploy, right? So what I want to do here now is just to show you a little bit of these artifacts. So this is all published in GitHub, so you can access it later. So first of all, this is something that we call let me close this here. I want to show you first the app. So here is the application. It's a Python application. As you can see, we have static files, the URLs. If you know Django, you recognize this. A normal Django application. And to package this into that box, you need to create a file like this, Docker file. And if you look, it's not too complicated. You just copy your Python requirements txt file here, install your dependencies, and copy your application inside that box, and that's it, right? There are Docker files that are more complicated than that, obviously, but I found this would be perfect for this session. Okay, so Django application in a Docker file, right? And I was testing this locally, so I had this Docker Compose. So if you are familiar with Docker, you're going to see here that I'm deploying the Django application here, and Iris over there, right? And they see each other. Okay, so now that you know a little bit of Docker and how we package an application, so let's talk about Kubernetes. So what is Kubernetes? Let's take a step back and talk about Linux first. If you know a little bit about what an operating system does, it helps you, it gives you an API so you can easily talk to your hardware, right? I want to ask for memory, CPU cores, I want to access the disk, and I use the kernel, my Linux kernel APIs for that. So I don't have to write code in assembly, I don't have to talk to the hardware directly. It's easier, right? And when I'm running my application during runtime, well, it will just schedule your application to run, to use it. You can use the CPU now. Now stop, I need to run something else. And it schedules your processing. Make sure they don't step on each other, that they can access each other's memory. So the Linux operating system is giving you this abstraction, protecting you from the complexities of the hardware and making sure that your application will run smoothly. Okay, so I think we all know this, right? So what is Kubernetes? So imagine now that you don't have just one machine, but 100. And your application is distributed and is running on a number of machines. So you don't want to go install your application manually on each one of those, right? And some machines may have GPUs, some may have maybe ARM, others may be Intel, right? They may be different. They may be more powerful. They have 64 cores, and others may have just 8 cores. So where are you going to run your workloads? So there is a scheduling happening here as well. So in the same way, Kubernetes provides you with an API to access your cluster and abstracts that complexity from you. You just say, I need to run this on an 8-core node. Kubernetes will see which one is available and put your workload over there, right? How much memory do you need? Do you need GPUs? You just ask, you declare what you need, and it will just allocate your workload to the correct machine. And at runtime, it will be doing this scheduling and monitoring and make sure they don't step on each other. So it's very similar to an operating system, but it's a data-centered operating system. Okay. So in the same way as Linux has a package manager, right, that allows you to package a software to install on Linux. Kubernetes also has a package manager. It's called Helm chart. So, because if you're deploying a distributed application, you may need a load balancer. Like I have my Apache farm, like I have 3 Apache servers there, right? And I need a load balancer. I need to ask for that, and Kubernetes will just give me one. I want to deploy Iris using IKO, right? And I want to run in 2 machines. You have to ask for it, and you need to ask for your disks, for your volumes. So the Helm chart is how you declare these things. So it's a package manager just like Linux. And if you bring this into the concept of smart data services and that catalog and that canvas that you saw, I hope you're making a connection here. So maybe what I'm seeing on that catalog, those things you are choosing, they are Helm charts, If you're thinking that, that's correct. But it has a special salt. Because a Helm chart is a very technical thing. In order for your application to be listed on our catalog, you need to give us a little bit more information, such as, what should I ask your user when it's time to deploy your application? How big it should be, like how big is the machine you need? You may give them options, or you may just declare as the owner of the application, I should be running on an 8-core machines, period. But maybe you want to give them t-shirt sizes, or let them pick freely. What endpoints are you exposing? Like I'm exposing this API that, let's say I'm a master patient index, right? So I'm exposing PixV2 and PixV3 endpoints, right? If I'm a Fire repository, I'm exposing a Fire endpoint. Maybe you need some secrets, like a license that a partner will provide, or some credentials to pull your images from the container repository. Maybe you have dependencies. You can't deploy me if you don't have a Fire repository, if you don't have a master patient index. I need to talk to it, right? And also user interface endpoints, like, okay, once I'm deployed, what am I giving the user? Like, do I have a UI they can navigate to, right? Maybe you have documentation endpoints. So those are all things that you describe in a file called SDS-YAML. So I want you to take a look at that. It's just a quick view under the hood. I know some people here, they know a little bit of that. So this is the folder where I have my Helm chart. And I have here two things. A deployment. So this file tells Kubernetes, remember the operating system of that data center, to deploy my Django application. And this file, it tells Kubernetes that I need a load balancer. So you don't need to fully understand all that is here, but these are all standards. This is all open source, and we're just adopting this amazing technology, but taking it further. So SDS-YAML is where you start declaring what are the questions you want to ask your users. What is your end user license and service agreement if you have one? What is it? What is the endpoint that you're exposing for the user to click and get into your software? What are the dependencies you have, right? What is the compute that your application need? Minimum CPU size, maximum CPU size, minimum run. So many things here that we were seeing on the PPT. So this one single file allows you to, allows the control plane, that canvas you saw, to ask the user everything that we need to know to deploy your app. So Kubernetes, this is an example of a Kubernetes cluster. So you can see the cloud here, like AWS, whatever, and we have 3 nodes, 3 machines. And the Smart Data Services control plane is right here. It's running inside the Kubernetes cluster. And it's that canvas that we were using before. And I have a load balancer here that allows my user to access it. Okay? Another thing that I want to tell you is that this control plane, if you ask yourselves, like, where are you getting all this information for the catalog? Like, you're listing applications. You show me this Helm chart thing, but I should put this somewhere, right? So that this thing can find it and list it there. Well, there is this thing called a Helm repository. So you can have your own. It's super easy to have one. and you can just publish your Helm chart over there. And then you can go to the control plane and just tell that there is this new Helm repository that you should pay attention to. And it will periodically scan these repositories and see what services are in there and add it to the catalog. So imagine you as a partner going to a customer, to an InterSystems customer that is already running the Smart Data Services control plane, and you're telling them all about what you can do, and the next thing you can say is, just add my repository, and you should be able to try it. You should be able to see my application listed on your control plane, on your canvas, and just try it. And we can try it together with your data, right? This is, you saw this already, right? So the control plane is right there. It's just another application that runs in Kubernetes. And a user is right here saying, I want to deploy that thing. This partner told me they have this cool thing. I wanna see it right now. So what happens is, if I click it again, it deploys. So if we're using the to-do application example, the blue circle is the to-do application, and the JDBC connection to the green circle is that dependency that got satisfied. So two services that I'm composing together. I'm using a very simple example here, okay? An application that uses JDBC. But imagine this applied to, like I said, file repositories, PIX v2, master patient indexes, even an application that is offering a JDBC connection plus a data model for a use case. So I have this IRIS instance, but that offers a data model for logistics or a data model for solving asset management issues, right? That is ready to get your data to solve that particular use case. So it's more than just a technology. We are trying to add a little bit of semantics to this dependency. Yeah, one thing that I wanted to show you is what is happening when I'm deploying these things. So previously, before I started, I got a list of nodes in my Kubernetes cluster, right? So I have here like 1, 2, 3, 4. I should have counted this before. Okay, I'll count it. 1, 2, 3, 4, 5, 6, 7, if I do it right. 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 22. Okay, and 22. And if I ask for it again, you see that it's bigger. You can see also by age, right? You see some nodes here that are here for 17 minutes. So the cluster, it grew. It had a number of nodes, and it grew to more nodes. Because, going back to the picture here, as I deploy new things, Kubernetes is helping me and asking the cloud provider, give me another machine of this big. I need another machine with 4 cores. I need another machine with 8 cores. It's doing that under the covers for you, right? So it scales your cluster. And after you're done with that thing, you can, when you delete it, it will scale back, right? So let me see here if I can show that happening. So I have this thing here. We're close to the end. I want to leave some time for questions. So this is the list of nodes. I will just deploy the to-do application that I have been talking about. And this is it. To-do. Okay, so I'm picking a size, a four-core machine, right? I want to see the front end, so I'll click here. I want to satisfy this dependency here. This application requires an IRIS database, a JDBC endpoint. So I'll tell it to use the Global Summit one that I used before. I need to provide credentials. So I'll put here a credential that I still have to enable on IRIS, and I'll add it. So right here, you see it's deploying. And if I say kubecontrol, get pods, namespace, to do, you'll see that it's pending. Okay, it's very small, right? It's pending because my cluster is not big enough. So it's asking AWS right now for me to give me another node, right? And eventually, this will start deploying the application there. In the meantime, I deployed this with you before when we started this session. I will just click here in Manage. You see the endpoints that I have access to, like Web Terminal, SQL, the list of processes in IRIS. So I can click here on SQL, but this is a brand new deployment of IRIS, so it will ask me to change my password, right? So we'll just do that. And I can access. So here you're seeing an example. Oh, that's the speed test running, right? It finished pre-expanding the database. So you see, it stays blinking like this until the machine is ready and the software is deployed. Well, there you go. It should be running now, right? So it should stop blinking. There you go. It stopped blinking. So I'm going back and forth. You see the front end, and I'm looking under the hood inside the cluster. And the to-do application is now here. If I go to manage, I just have to-do app because those are the endpoints that this application declared to offer to the user. If I go back to IRIS and manage, I have many other endpoints, right? But to-do just have this one, and I can click, and it will blow up in my face. Okay, that's what happens when you're giving a demo. But I hope you get the idea. We want to start creating use cases and packaging them in such a way that someone that is trying to find, let's say, I want to find a solution that will help me find patients that are at risk of developing diabetes or chronic renal disease, or a logistics solution, whatever. You could just type it here, find a solution. The solution will tell you what you need in order for it to be deployed, and will promote this composability, but also help you get it deployed. And because it runs on top of Kubernetes, we can actually run this on any cloud and also on-prem. So if you have an airtight installation, you could have this on-prem as well. So that's basically what I had to share with you. This is a sneak peek into what we are developing. And if you have any questions, oh, the gentleman there.
Thank you. Marcus Davis from Integrella. I thought it was a good presentation. I really think you explained it in a very easy to digest way. This SDS YAML, is that a kind of config-based representation of what you had inside the kind of canvas there?
Yeah, let me show you one. So this one here is the one for the to-do application, right? So here it's saying I need an IRIS username and a password, and I'm exposing this to-do app endpoint. The user can click on it to get into my application. So that's exactly it. You go to the catalog, and you go to that application, and you see that it's asking for a username and password. And this, let's talk about dependencies. This dependency here, it's saying I need a JDBC connection. So this section here is asking the user, please satisfy this dependency. This is authorization. I need you to authorize me to expose this outside the cluster. Like you may deploy something without exposing it outside the cluster. So this is an external service declaration here. So all these things you declare here, they help design this page, and also the title of your solution, the icon, the description here, the company, all these things, they are not part of the SDS YAML, but they are part of the Helm chart.
Okay, I think it's very good that you can visually see it. You know, it makes it easier to use. But in practice, do you imagine that people will use the config files because that will you'll be able to check them into Git, have version control, auto deploy them, things like that?
Yeah, each partner can have their own pipeline, right? If Git is an internal thing, you as a partner can put your source there and then build your product, push this final artifact to a place that can be protected. So like you don't want anyone to be pulling your software without asking permission, right? So there are credentials that you should be able to give to a customer that needs to use this application. Here, for instance, I pushed these images to a public repository. But the Git stuff, it finished a long time ago. It's inside my company, right? So I'm pushing final artifacts to a repository so that this thing can download. You may be thinking about configuration, and I want to save configuration. Like, okay, all these choices here, I want to save on Git, right? And that is also a good practice. I just want to separate source control from configuration management. And the beauty of this is that it's built for that. So there are Kubernetes plugins like Flux CD that take your config and save it on Git. So you can have a canvas like this that is your dev environment, and people are deploying stuff and deleting and deploying and deleting and playing with it. But maybe some project, you wanted to take it to the next cluster, to UAT, to production. And that configure, all these choices you made, they can be saved on Git and then used to redeploy the solution on the next cluster. Does this answer your question?
Yeah, I think that makes sense. I don't want to hog the mic, but the one last question,
okay,
if I may. So it sounded like you wanted to get partners involved in building some of these. And say, for example, we built something to connect to a Murex trading system or something. That service might work with this particular version of Murex, but then when another customer comes to use it, they might be on a slightly different version. But how would that all get supported?
Now, thank you for asking that. I will repeat the question this time, right, for the recording. I may have a dependency. I'm an application that may have a dependency on something else. Let's use the example of Fire repository, right? But it has to be Fire v3, right? I haven't been doing a lot of Fire lately, so forgive me if I'm saying something stupid. And all you have is an old Fire repository that is Fire v2. So the dependency, it should be as clear as possible. So you should say the version. and we should be using semantic versioning on these dependencies. So we have Pix v2, Pix v3, and that's what you should be saying, v2, v3, and the version of things. So we want to say what is it that you need and what is the version. So dependency injection can help you. And maybe, okay, you can work with a newer version of that dependency because it's just a patch release, for instance, right? And semantic version can help there. Okay, I haven't been given the sign that I should get out of here.
No, it's not like that. If anybody does have further questions, you can take them offline. But we have two more events in here.
Sure. No, I'm just, no problem. Thank you.